Yes, good afternoon and good evening to one and all present here.
Yeah, good evening.
Dear authors and invited guests, welcome to technical session 3A. Myself, Deepika Jain, and this session will be moderated by me. On behalf of Global Knowledge and Research Foundation, it is my great pleasure to welcome you to the International Congress on Information and Communication Technology, ICICT 2023, London, United Kingdom. The 8th edition of this conference is being organized in a hybrid mode. The physical event was held in London, UK on 20th and 21st February, and the virtual event will be held through Zoom today and tomorrow. I hope you will enjoy the 2 days conference and interactive sessions. In this session, we have 6 presentations and each presenter will be given 12 minutes to complete their presentation and 2 to 3 minutes for the question and answers. And if there is any query, you can drop your questions in the chat box, which is open to all. And I would like to introduce to our session chair, Navneet Sharma. He is an associate professor of Department of Computer Science and IT. University. He has 17 years of teaching experience of UG and PG classes. He is associated with various research organizations and universities and services. Associated with more than 15 universities as well. His research work, he has done research work on e-commerce, cloud computing, network securities, etc. I welcome you, sir. We also have another session chair with us, that is Jane Christian. She is an instructor at Bulacan State University, Philippines. She did her Bachelor of Science in Information Technology from Bulacan State University and Master of Science in Information Technology from University of La Salle as well. I welcome you, ma'am. Ma'am, you would like to introduce yourself, a quick brief if you want to about yourself.
Hello, good evening to everyone. I am Ms. Jane Christine Suarez. So I'm from Bulacan State University, Philippines. I am currently working under the College of Information and Communications Technology. So I do teach capstone project and programming subjects. And nice meeting you all. Thank you.
Thank you, ma'am. Just a minute. All right, so we can begin with our first presentation, that is, do we have Narek here? Okay. Anna Tapol, are you here, ma'am?
Yes, this is speaking of Dalian from Armenia.
Narek is here. All right, all right. So we'll begin with the first presentation. Narek, you would be presenting a paper on development of a method for reducing the impact of metal interconnection parameters and on the speed of VLSI. I welcome you, sir. You can start sharing your screen.
Okay, thank you.
Please share your screen, sir, and please, all the participants, please take care of the time frame which is provided to avoid any further delay.
Okay, thank you. Today I will present the development of method for reducing the impact of metal interconnection parameter on the speed of VLSI designs. The author of articles, Narek Avdalian and Armen Petrosyan. About of interconnection. It's well known that advanced chip contain billions of transistors. This is an incredible blowing fact to be sure, but did you know the large-scale integration chips about the size of fingernail can contain 13 miles of interconnection wires in text levels. These wires function like highway or pipeline to the transport electrons and connect transistors and other components to each other and make their functions. And just as the speed you can drive your sport car depends at least in part on how clothing the freeway is a chip performance depending on the ability to move signals and power through these ultra-thin wires. In fact, as the shrinking of future dimensions, scaling as a continuing interconnection are now becoming to span bottleneck in today's most advanced chips. So let's spend a little time learning about them. In this slide, you can see an example of the modern IC where metal layers and interconnection are shown here. You can see we have a two levels metal connection, and then we have two types of interconnection. The local interconnection are due to the transistors gates here you can see, and the global interconnection are higher metal connection that are the thin metals connected elements of the macro levels. Here you can see the capacitance of the metal lines overlapping. One of the modern technology problems is the increasing of the integration degree, which allow to. One of the modern technology problems is the increasing of the integration degree, which allow to distribute as many logic elements as possible in the unit area. As a result, the number of the elements per unit area increasing and leads to an increase in speed. But it isn't a hampering by increasing in the number of metal interconnection that leads to increasing delay due to the increase in the coupling capacity of the interconnection metal line. This slide shows the main components of metal capacity due to the metal line overlap. As you can be seen from this slide, the main capacity that can affect the signal is the C2. You can see here, C2. In this graph, the capacitance due to two parallel metal M1 metal layers at a certain distance. C1 describes the capacitance between the first metal layers and substrates. You can see here, this is the capacitance. So the C3 describes the capacitance.
Sorry to interrupt you. I think your slides are not moving.
Okay. So
try to display it in the slideshow view.
So the C3 describes the capacitance due to overlap of different metal layers, and the ox here, this is the characteristic to the distance between two metal layers. This is a metal layers M1, you can see here. Then the second metal 2 layers M2, and the last metal layers M3. In this slide, you can see the formulas for calculating the capacitance you see in the resistance of metal layers. You can see here the formulas, which is calculated the capacity. So the here represented the capacity of the general system will be calculated by following formula here. And then here you can see the resistance of metal layer is calculated by following formula below. And then the last part I am representing the signal delay in the metal conductors in determining by the following formula. Here representing the formulas about the inductance of metal layers, which is calculated for in this formula. Then here we are representing the delay for the calculation. In the general case, the delay in the system will be expressed as the following here. tau RLC equal to tau LC plus tau RC. In the general case, the delay system will be expressed as the following. We included the arguments, the numbers of arguments, which is getting the correct results for the delay analyzing. And here I am representing the sequence of algorithm steps on the method. The first step, it is the necessary to the model the metal layers of the systems. The second steps access the resistance and capacitance value of the given system, which are represented by array R1 to Rn and C1 to Cn. And the next steps, the classify resistance and capacitance values in descending orders. The fourth steps, find the main mathematical expectation for the values of resistance and capacitance. If the average mathematical expectations of the capacitance is generated on the corresponding value of the resistance, it is necessary to change the metal layers and start comparing the average mathematical expectation again. The step 6. In case of the reverse fulfillment of the condition, in point 5, one should try to reduce the high metal layers and compare again. The 7 steps, 5 and 6 points should be done as many times as possible to get the most centralizing value for the both resistance and capacitance. In this slide, you can see the simulation results. Where we use the connection, inverter, and buffer. We are analyzing the rise delays and fall delays times for depending the distance 1, 2, and 3 UMs. We have using the metal M2, M4, M6, M8, and M10. Here representing the results for rise delay. Here representing the results for the fall delay. The next slide representing the results of the depending of current consumption of the inverter buffer unit of distance here. The right side representing the results capacitance depend on the net lengths. The horizontal, this is a 1 UM, 2 UM, and 3 UMs. The next slide, I am representing the simulation results when using the inverter connected to NANDs. The same analysis for this. We have also analyzing the rise delay, the fall delay. The next slide, I am representing the simulation results about of the current dependence. The current depend on the net lengths. So the right side representing the capacitance depend also the net lengths. Here the final simulation results about of the inverter connected to NOR. So here also representing the result of rise delay, fall delay. The next slide about of the current and the CAP results depend on the net length. So the final part of conclusions. The development method allow to evaluate the capacitance and resistance of metal layers of any design. The developing method allow to reduce the capacitance and the resistance value of metal layers. The work considers simple example of logic elements in which case the applied algorithm ensure a reduce of delay time by up to 8 to 10%. It is obviously that is large systems, it can provide better results given the large number of interconnection methods. The development method does not carry out to reduction in a full automated way, and the user needs certain design knowledge to apply it correctly. So it's all. Thank you for attention.
All right, so thank you, Sir Narek, and that is a very interesting topic about BSLI, and I would like to inform everyone that you can type in your questions into our chat box. For my personal question, Mr. Narek.
Yes.
Um,
No. Go ahead. Sorry.
Yeah. What is the rate of speed that increases in the development of BSLI circuits?
So this method about of the minimization the RC, minimization the interconnection resistance and capacitance value. When we decreasing the resistance and capacitance for wires interconnection, then we speed up of the designs. After that, our design is a speed up, so increasing the speed.
Okay, all right. So great. Okay, thank you for your wonderful presentation. And let me check our chat box if there is any questions. Okay, all right. So it looks like we've covered all of your topic, and let us proceed with our next presenter.
Thank you. Thanks for your attention.
Thank you.
Hello, I believe you all should be able to see my screen. Today I will be presenting on machine learning prediction of intellectual property rights based on human capital factors. And before we get into it, just a brief note on me and my co-author. A little bit about me. I'm a PhD candidate at Claremont Graduate University, and I study international political economy and computational analytics. My co-author, Karina, she was also a PhD at Claremont Graduate University, but she graduated in 2021 with a degree in computational analytics, and she's now an adjunct professor at La Sierra University. Let's get started. So the primary topic for our research are human capital factors and intellectual property rights. And so the established paradigm in the political economy literature has human capital as primarily consisting of two factors: education as well as learning by doing or experience. And what we'll be doing in this research is looking at the different factors that combine into this education and learning by doing in human capital to understand which ones are the best predictors of intellectual property rights. When we're referring to intellectual property rights or intellectual property protections, this classically refers to patents, trademarks, copyrights, or trade secrets. And so these are protections given to intellectual property in an attempt to stimulate innovation, research and development, and economic growth in line with various economic growth models. This research has two primary research questions. The first of which is, does human capital attainment stimulate increased IP protections? And which forms of human capital in an economy have the greatest effect on IP protections? And before we go further, just a note about the analysis we're doing. This is a descriptive analysis. We're trying to explore the relationship between the variables. The goal of this research is not causality or to determine the causal pathways between these variables. When we think about the previous literature, there's a number of different articles we could reference, but we highlight these four because of how they interact between human capital and intellectual property rights within the economic paradigm. Local in 2020 identifies that higher human capital nations are better equipped to use intellectual property rights and identifies the complementary role the two factors play in promoting entrepreneurship. And this has to do with, as you can see lower down on the presentation, the internalization and implementation of technologies. Higher human capital nations and societies are better equipped to identify new technologies, internalize them, and implement them into new technology in the form of patents or products. Sork and Dewar found similar results in 2016 when they were looking at the dynamics of the two factors together to maximize economic growth. They found that at low levels of human capital, you want low intellectual property rights to promote growth, but at high human capital, you have high intellectual property rights promoting growth. And so this brings questions about how they're exactly interacting and which factors are interacting with each other. Gould and Grubin in 1996 provided a really interesting early example of the explanatory power human capital has on intellectual property rights in their extensive research on intellectual property rights and economic growth. And finally, we note Chen and Putitanens, and they find substantive significance, but fail to find statistical significance in their research that used education instead of human capital as an effector of intellectual property rights. But research on intellectual property rights highlights the influence of tertiary education and higher education on intellectual property rights, and therefore the operationalization of human capital as secondary school rates may be a misoperationalization of that concept, which may be finding a potentially inaccurate result. Our own theory highlights human capital factors as drivers of innovations primarily through two mechanisms. The first of which is higher human capital societies, in line with the research of Sork and Dewar, as well as local, are better equipped to internalize and implement new technologies, and they're better able to capture the innovation returns, and they have a greater desire to capture those innovation returns. Therefore, you'll see this drive for higher intellectual property protections. When looking at our research design, we focus on two data sets is where we get our data. Janarti and Park came out with a breakthrough data set on patent protections in 1997, and then further updated it in 2008. And we use them for our IPR protections data. And then cross-national time series 2020, we get a number of various variables from there to be our explanatory and control variables. And this creates a data set of 945 observations, cross-sectional data. Our dependent variable is IP protections, and our explanatory variables include university enrollment per capita, physicians per capita, book production per capita, internet users per capita, personal computers per capita, and passenger cars per capita. And we undertake a couple of different modeling approaches in order to answer these research questions. So with the goal of which the machine learning techniques aim to identify the patterns and predict intellectual property rights using the key indicators. And we also include a number of control variables, which I can talk about later. But we use regression models. So we use regression, which works similar to OLS, but has a penalizing parameter. We have regression trees, which grow a tree, then prune it to produce the best subtrees before undertaking k-fold cross-validation to analyze it. And then you have a random forest, which produces 100 trees, and the lowest mean squared error tree is the winner. Finally, we also create classification models, which make use of an artificial neural network to predict IP protections. And we transfer this to a classification model by looking at the mean and median of IP protections and creating a binary output based on that. The results of our research are listed here on the right. So on the right, you can see in table 1, the training and testing performance of the 3 regression models, and the random forest performs best if you look at the test data based on its lowest RMSE and its largest R-square. However, it's clear that the regression models suffer from overfitting issues, as the difference between training and testing is quite large for several of those. Of the random forest, the 5 variables that were found to have the highest predictive importance were electric power production, GNI per capita, which we identify as indicators of level of development and specifically economic development. Additionally, university enrollment per capita and physicians per capita were found to have explanatory power for IP protections, which gives credence to human capital factors affecting intellectual property rights protections. University enrollment per capita is quite clearly education. However, we also feel physicians per capita is a good indicator of the educational attainment of a populace, as you need a high education as a prerequisite to become a physician. Finally, percentage annual increase in population is an interesting one that requires further research and potentially indicates the demographic effect on intellectual property rights. Finally, the table 2 looks at the 3 different neural networks we created that have various layers as well as nodes in the layer, and they indicate that based on the variables included, we can predict highly effectively the intellectual property protections, as you see, at 0.85 or higher. In conclusion, human capital factors do affect intellectual property protections, and this primarily occurs through education and not learning by doing. And this is seen based on the university enrollment per capita and physicians per capita. However, the exact nature of this relationship is still undetermined. A reminder, this is an explanatory analysis, not a causal analysis. Recommendations for future research and limitations of our research. So based on the exploratory nature of our analysis, it limits the recommendations. However, future research should build on ours and investigate the exact causal pathways between these variables. And it should also look at the direct versus indirect effects. Machine learning techniques can capture indirect effects that are often overlooked by direct analyses based on OLS and other simple regression techniques. And finally, further research should look into the element of human capital that is experience or learning by doing rather than education as a stimulant of intellectual property protections. Finally, 3 limitations potentially are the lack of causality looked at in our research, the directionality of the effect, are human capital factors affecting intellectual property rights, or are the intellectual property rights affecting human capital factors? This is something that needs further research. And finally, there could be arguments about not including enough control variables and potentially the interaction between human capital and intellectual property rights occurring through R&D or other variables that may be skewing our research. Thank you very much. Any questions?
Yeah, a couple of questions from my side.
Yes.
Session, I have a few questions. For your analysis process, which type of parameter you have chosen?
What are my variables?
Yes, for the machine learning algorithms and all, what type of parameters you have chosen?
I've chosen a variety of different variables from the cross-national time series and Janarte and Park index. So Janarte and Park is the IP protections data. And then the cross-national time series provides the data for the others. The explanatory variables are university enrollment per capita, physicians per capita, book production per capita, internet users per capita, personal computers per capita, passenger cars per capita. And then in addition, we also included a couple of control variables such as GNI per capita, and a few others.
Okay. Okay, nicely presented. Any other question from the other side?
I would like to ask Jason if what do you consider as the most good predictors of intellectual property right on human capital?
So the best predictors of intellectual property right based on human capital are the 5 we identified here: the electric power production, gross national income per capita, university enrollment per capita, and physicians per capita are the 2 that primarily refer to human capital. So those are the 2 human capital factors that we identify as affecting intellectual property protections.
Okay, all right. So thank you. Thank you for sharing your study, and congratulations.
Yeah.
Thank you. So we have our next presenter, Anna Tapol. She would be presenting a paper on procurement of the future, investing today in the technologies of tomorrow. Anna, can you hear me?
Yes, I can. Thank you.
Yes, please. So you can start sharing your screen.
Can you see my screen?
Yes.
Wonderful. Welcome to everybody. And today I will be presenting on the procurement of the future. My co-author, Elizabeth Koopman, is also on the call. This study was part of the IBM Academy of Technology initiative. And I just wanted to bring this up because this is a study of people with very diverse backgrounds, from people who actually know procurement to people who know security and quantum computing. So I just want to bring this up because I think when we think about the future of changing industries, future of changing entities like procurement, we truly need to look at the diverse disruptive capabilities that are coming up. So let's start this by looking at the history of procurement. We're looking up to the future, so let's first look at the past. I think the strategic procurement was one of those very important milestones in the history of procurement in the 1980s when we started truly globalization. And so companies who had to take care of the globalization really looked at their own managed risks related to third-party relationships. At that time, also, rise of the enterprise planning system took place, really looking at ordering, receiving, invoicing, and payment planning. Huge changes occurred between 1990s and 2000s when emergence of the software tools to computerize procurement took place. And that's when we had the establishments of the category management, supplier relationship management frameworks that really brought the comprehensive means of deploying supply chain management. And now, past 2010, we are in the era that we often call the digital procurement. Clearly, all of us are witnessing ability to add analytics and insights, bring in artificial intelligence and automation. And I think the biggest change that we are looking at from society point of view is that the procurement starts changing from just looking at the value for the procurement from cost management perspective to those additional, maybe social embedded perspectives as well. That is brought up absolutely because of the new technologies that are being added, the disruptive technologies we see around. That includes, of course, artificial intelligence. That includes Internet of Things. That includes, if you think of new capabilities, things like intelligent workflows and others. And I think this is very important because in addition to the disruptive technologies, we see other disruptions like pandemics, like natural disasters, showcasing to us some of the weaknesses of the systems, specifically supply chain just-in-time capabilities. This really drives the new look into the supplier relationships. This looks into new capabilities and maybe collaborations we have to deploy around this ecosystem-based value. And most importantly, the social and individual goods value, as I mentioned. So as any appropriate scientific methodology, we first study, right? So the first step is to study where we are. And so you have here on the left side, a work done by this team to really identify the top challenges for the transition and transformation of the procurement. Supply chain disruptions, as mentioned, increase global legal and compliance complexity, process transformation challenges, and there are many of them, few of them are listed here. Fraud detection, of course, and now when we look at the workforce as well, supporting diversity and inclusion, supporting many different capabilities related to ESG initiatives. Now, we have a team of technologists, and so of course, we looked where are the top opportunities, and on the right side here, you have mapping of various technologies currently available and upcoming. And the mapping is based on some importance of those technologies, and I clearly labeled this slide. This is 2022-2023 view. Over time, of course, that this mapping may change, and then feasibility of deploying some of those technologies. So on the top right corner, you see technologies like API-based economy for microservices. Those technologies are right here, and we clearly need to put more pressure for deploying the hybrid cloud native type of applications. On the left side, you have quantum computing. The technology is also here, but we clearly see much less adoption of it at current time. And so again, going back to the scientific methods, you study things and then you put in the hypothesis. And our hypothesis was that if we want to move from the left, where we are right now, when we are trying to solidify the foundation of the strong procurement, sustainability, I mentioned, digitalization, deployments of AI and blockchain, and we want to move to the future vision of procurement, the predictive, autonomous, fully digitized processes, responsible, traceable, risk-managed sourcing, and nearly instantaneous ordering or delivery and then payments. Our hypothesis is that we have to be very prescriptive in creating the roadmap to get from left to right, and having some milestones critical that would be in the midst of this roadmap that we need to also identify. So this is adding some of the disruptive technology and really changing the monolithic procurement capabilities of today. And in my talk, I specifically will talk about the ecosystems and data and AI as a key features that we need to enable. So now, again, scientific methods. So we went through study of what's the challenges. We went into putting the hypothesis of what we want the procurement to look like. And so now is this moment of testing and iteration. How could we build this procurement of the future? What are the features and functions that we want to absolutely deploy and enable? We focused first on ecosystem. This was a very important part to us because we see this as a big change for the procurement of the future. The networks and ecosystems being very different and business models being very different. But what those ecosystems are supposed to deploy, they're supposed to deliver a pieces, think of it as a puzzle, right, for the procurement of the future. And so what you can see around here are the construct of key features that we want with enabled technology right behind it. And so if you think of on the right bottom side, sustainability and risk, clearly we want to make sure that ethical and sustainable sourcing, is part of this. If you look at the left-hand side, if you think of invoicing, processing and payment, clearly B2B digital payments is a necessity, right? And so when we look through this venue of ecosystems, now you can group suppliers and vendors that enable the specific components that we need for the system. Now, all of this absolutely has to be enabled by great communication, service, self-service, data sharing, integration layer, and of course, personalized user experience. So that center is where all of those capabilities have to be focused on. And that was very clear to us that one of the challenges we clearly focus right now is related to data. I think if we look at the procurement, you understand right away that we have contracting, suppliers, invoicing, inventory, government regulations. There's a lot of operational data. That data is not always accurate. Most importantly, that data is not shared across various business units. And so if we want to really think of the procurement of the future, we absolutely need to look at the needs of accessing this data across the systems and sources, regardless of the format or template of that data. And most importantly, being able to match the operational data, so internal data, with external sources and market data. Only then we can truly think of enabling the machine learning infused strategic sourcing. Really, then we'll be able to do better spend analytics to shape and automate orders. And I think this is critical because we are realizing that enabling this data fabric and enabling good communication and the deployment of the data will allow us much better AI insights. And then we will free up resources that are much needed for this very complex view of the procurement of the future, and really address some of the more complex capabilities that we need to address, like high impact transactions, optimized cash flows, and so forth. So again, the team spent a lot of time, I just wanted to say, iterating. If we had this, what would happen? And so you have here just few examples of AI-enabled procurement of the future. E-sourcing clearly is a big one, and there's many publications around this. Category management, market screening, contract management. I think we all really understand that auto-determining whether the language of the third-party document is compliant or not with the policy is critical, but is not easy at all. Procure-to-pay solutions and so forth. So now we have a vision. We know of all various capabilities we can deploy. We have various capabilities we can deploy. The question is, what's the architecture behind this type of solution? And so what you can see here is ability to create a very flexible structure so that on the bottom you have your vendors and suppliers that have ability to bring marketplace foundation. You have then a very flexible platform to support IT that is vendor agnostic. Then you have that data fabric, then I will talk about this a little more. And most importantly, now on the top of this, you can bring the procurement solutions with the layer of communication that really allows you personalization. Now, this looks simple, but I want to state this is not simple. I just want to be very clear that just 4 major blocks that we absolutely realize while building it are listed here. And there's more. I just want to say these are the critical ones that we see. First one is the communication layer. We need to adapt the asynchronous communication between various applications. We need to be able to absolutely enhance the performance of cloud native applications. We have to have event data consistency. That's what I talked about this in the past. Then let's move to this data. Since we said that data agility is very important, the data fabric, the capability to store, manage, clean up data, make sure that we have a pipeline of data, make sure we have data lineage, will be absolutely critical. Well, once we have the communication layer and once we have the data fabric, then that's when we can truly build on capabilities of insights and AI, allowing us time windows into the reasoning, which is very different than just analytics. Looking at the aggregates between multiple data streams and truly looking at complex events in the procurement. And then the final block, I think, is very important. We are talking here about creating the flexible infrastructure, but it has to be a trusted infrastructure. Our vendors and suppliers have to want to work with our organizations. And so smart contracts, truly based on digitalization, a single source of trust would be absolutely critical. Now that brings us to this roadmap. I just want to say one more time, I'm sure it's not a full roadmap, but what we are showing on the left is
a lot of time. We need to conclude, yeah?
Of course, this is last slide. So on the left side, we have the solidified foundation of the capabilities. On the middle is the roadmap for what we can be looking on in a year, 2 years to come. Start looking at it right now. And then on the right side, you have the next generation capabilities, including metaverse and others. With this, I conclude. I thank my co-presenter and co-author of the paper and the IBM Academy of Technology. Thank you.
All right, so thank you, Professor Anna, for that very informative presentation. And I would like to ask a question about, do you have a sort of an evaluation tool that you used in determining the procurement of the future, such as you have mentioned about strategic e-procurement and digital procurement?
Yeah, so I just wanted to say, I think the challenge is, so if you think about the procurement, I think if you just look at this one, each one of the capabilities in procurement, so like if you think about supplier management, or if you think of source to pay, has different tools, right? Like if you really think about the breadth and capability of procurement, it's such complex. And by the way, each vendor, each supplier has a very different capability. And so when you start trying to think what are the tools you use to then test those capabilities, is even more complex. And so that's why when we had our team of specialists, we wanted people who are not just procurement specialists, but security specialists, technology specialists, because I think the diversity of thoughts then breaks the standard way and approaches and really looks at transformation, which was so necessary right here.
All right, great, and congratulations.
Thank you. Thank you for your presentation. So we have our next presenter, Elizabeth, who would be presenting a paper on Society 5.0, a vision for a privacy and AI-infused human-centric society driving a new era of innovation and value creation. Elizabeth, are you here?
Yes, I'm here. So let me just
Please share your
see
screen.
how I can share. Okay. Oh my God. Okay. It's actually not set up on my Zoom ability to share. So I have to open system preferences. So the only what we can do, Anna, if you can share that presentation, and basically I can talk about that. I will see if I will be able to accessibility. Okay, so is that okay if we will do, because otherwise I will lose time while I will be
No
changing
problem, no
that.
problem.
Okay,
You can,
so Anna will be sharing the slides, and I will be basically talking. And before I start with this, I just wanted to add one comment in regards to the procurement. There was a question about assessment. As a part of that study, what we did for procurement, we actually developed a framework to identify maturity of the company in the procurement space, okay? And this is a part of the IBM IP. So now we are going to the Society 5. So Society 5, a vision for privacy, AI-infused human-centric society, driving a new era of innovation and value creation. So again, this study, this paper is outcome of the study that was part of the IBM Academy of Technology that I led, and it was calling Society 5. It's already the second paper. One was already published at the Springer Books, and this paper together written with Anna, and we are very excited and hope that we as a society will be moving to Society 5 in the future. So what is Society 5? So Society 5 was introduced by government of Japan as a new way to resolve some of the challenges in the society, especially, for example, in Japan, you know, they have the elderly population, right? So they want to see how they can bring technology together and resolve some of the societal problems. Okay, so it's a new way to look from the human-centric perspective, right? And this is where we can develop new set of services using new advanced technology and deliver these services to the people who need them at the right time when they actually need them. So our study was looking, this paper actually is focusing on describing some of the challenges that we need to address in order to realize Society 5 vision. You know, we all went through the COVID-19, okay, and in some areas we still see the challenges, we still feel the effect of the COVID. So pandemic actually presented and showed us some of the challenges that we, you know, and pointed at some of the really very, some of the pain points that we have. And this pandemic, I would say, it's accelerated more about ecosystem thinking, which is very important for Society 5. Again, the way how we used to work, how we used to live, how the businesses interacted right before pandemic, it's basically changed. I think right now, everywhere as a society, as a different areas, we are trying to address some of these challenges, and we're trying to see how we can resolve them. One of the disruption, what we saw, the biggest one, was around supply chain, right? And as a part of that, this is how we see that the industries are connecting. They need to collaborate more in order to deliver the services. Because if you look, for example, like, you know, I give the simple example, which actually not included in our paper, but it's about in the healthcare. It's about medical devices, electronics industry, right? Healthcare, pharmaceutical. So if you look at this is really a very, very connected environment, right? And after that, we have in the middle, the human, who actually is required some of the services that will be delivered by, you know, by each of these kind of like industry. But in order to deliver the better products and understanding what exactly is required, right? It has to be connection, it has to be collaboration. And in order to empower that collaboration and enable that, right? Sharing of the data is actually a very critical aspect. It is very important. And sharing the data, that's how you can infuse AI. And you have to ensure that your data is protected and secure. To the next slide. Right now, we are in Society 4. And from the Society 4 perspective, we need to move to Society 5. So if you look at the Society 4, it's more on the, it's called Industry 4, right? Revolution, right? This is where on this table, we actually summarize it, some of the differentiators and some of the aspects, how we need to move forward. So from centralize it, we are moving to decentralization of control and power, right? And this is, again, this is where we are talking about the ecosystem aspect, right? So we need to, oops, you're moving very fast. Okay. Anyway, so we are moving to the, you know, we have to reform our industry. This is where we are connecting physical and the virtual space, right? And bringing that together. And this is how we basically can address some of the, you know, analytics, bringing analytics close to the edge. So from the consumer perspective, right, this is where we are again talking about human-centric. And if in the past, and right now still we are looking at the output based, outcome based. So here it's more about value creation, how we can create value. And what exactly is the value? Because, you know, for one party, it may be a value, but for another one, it may be not a value. I'm looking at the time. And definitely, we have to look from the sustainability, from the ethical perspective, and which is absolutely very important, and data democratization. Can you move to the next slide, please? Okay, so this is where how we can monetize and create value in the society 5. So this is how we are moving from the enterprise-centric view more to the industry and societal value net creation, okay, which is we called human-centric. Okay, let's move to the next slide. I want to talk more about the how we can utilize data. So transition to value, this is where we are kind of like changing the industry boundaries, where we are more focusing on the value-based transaction, value creation. And this is where we're exploring new routes, new models, how we can actually deliver that value. And this is all about decentralizing and democratizing the system, okay, moving to the new level of actually connecting, building ecosystems of ecosystems. Okay, going to the next slide. As I mentioned, the very important aspect is about utilizing data to deliver new insight. Right now, we are talking a lot about data, about AI, how we can deliver new insights, right? So there are different levels about these new insights. I would say that right now, probably in our society, we are more on this descriptive, to some degree predictive. We want to move to that prescriptive, cognitive space where we actually can utilize, analyze the data, right? And understand that data, and actually not just deliver something which, you know, is analysis of the past, but basically deliver the new ways, new insights. For example, let's say before something is happened in the society. Okay, move next, because I have only 3 minutes left, so I want to cover everything. So how we are doing the data realization? So there are many different aspects where you know, you can deliver the value, looking into the different, how the different industries are connected. So we put here a few examples. For example, oil and gas, shipping, chemical, agriculture. So if you look at this agriculture, right? So there are multiple different buckets, right? So this is the applications. This is applications that can use all this aspect in, you know, realizing the data value. It's banking, it's weather, harvesting, workers, right? It's disease, including like, you know, human, animals, and like, you know, corn. It's about private data where, like, you know, you have crop status, right? You can build the future plans about how you are going to plan your next year of your crop season, right? It's using public data, which is weather, which is availability of the workers, right? And understanding optimization, how you can optimize, you know, your services. And after that, services which is provided by the banks, stores, farms, and others. Okay, to the next slide, please. So here we are talking about ability, how we can share the information, about actually sharing the data, because, you know, one of the most challenges is that people are afraid to share the data because there is a privacy involvement, because there is IP. So it's a lot of different issues, and from our perspective, we still can provide the ability to share the information without actually sharing specific data. Okay, to the next slide. Is it the last one slide? Oh, I still have a few more. Okay, yes, 2 more slides. So one of the important aspects, how we do value distribution. So right now we have approaches about income approach, market approach, cost approach, right? In the future, we are talking about cooperative game theory approach. So this is where we have a group of players which are creating a coalition, and after that you have a coalition of coalitions, and after that where you have all the players, and this is how we can build the models, and after that we can apply the different aspects and train the models. Okay, last slide. I know it's almost the time. So what is the next steps? Yes, as we already said, there are multiple different challenges how we can achieve that. Moving to society 5, where sharing the data and apply AI is one of the most important aspects from the technology perspective. But in order to achieve that, there are multiple challenges, like we have to resolve some of the technical business regulations, right? We have to ensure that we have data quality, and it's not just applying the data, okay? Bringing the value, it's how you are bringing the different sets of data together, okay? Because you can get a lot of data, and at the same time you will be not able to deliver anything. So there are we need to address this legal relationship between different groups. We need to understand how we can distribute the value, and after that deployment of the advanced technology. Measurement, we also, as a part of this technology, we developed a value framework that we can apply, you know, for the moving to society 5 forward. So I would like to thank you everybody for giving the opportunity to present this for Society 5 and IBM Academy of Technology. Any questions?
Thank you for sharing, Ma'am Elizabeth. And for my question, I would like to ask, in transitioning from 4.0 to Society 5.0, what do you consider as the most challenging part of the transition?
The most challenging is ability to share the data, because, you know, there is different perspective around data privacy, and, you know, which is kind of like we need to share the data, but how we are going to resolve that privacy aspect. And this is also developing a new regulations. And after that, another aspect is how from the businesses, right, from the corporation, right, when you share the value, when you share the data, when you develop the new kind of like models, who owns that data? Who owns, so it's data ownership, AI models ownership, right, and distribution of that value. I think that's some of the challenges that we need to resolve. I'm not sure if we are ready or willing to do that, but at least we are moving from that, you know, where we are more thinking about human-centric, and basically what exactly is the value to the end user, who is basically each of us, right? Okay, that's my point of view. Thank you.
Yeah.
Thank
Thank you so
you.
much.
Thank you. Thank you so much.
Thank you.
So we are done with all our presentations. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the entire team, thank you for the support during the 8th International Congress of the ICICT, and we hope to see you in the 9th version of this conference as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the peoples have already forwarded the Springer board and the publication will be live within 6 months. And I request you to kindly cooperate with the team of ICICT. I also thank our session chairs, Navneet Sharma and Jane Christine. This is from our side for your token of appreciation. Thank you for chairing the session. It was wonderful having you here. Thank you so much, sir and ma'am.
Thank you.
And I would request the participants to turn on their cameras so that I can take a quick snapshot. Thank you. Thank you so much. Yes, any questions regarding the conference? I have dropped a message in the chat box as well. Thank you so much, everyone. Stay safe. Take care. Bye-bye.
Thank you.
Bye.
Thank you, ma'am. Thank you, sir.